Okay, so we're going to look at matrices and getting them into row echelon form or reduced form or Gaussian limitation, all basically mean the same thing. So we're starting off with a fairly simple one. 3x plus y equals 5 and 4x plus 2y equals 8. So we've got a 2 by 2 matrix. This is what's called an augmented matrix because you've got answers there. So let's have a look at how we solve this. Now, I'm going to use fairly similar terminology, I hope, but R2, we want to get a 0 here to solve it. So we're going to do R2 becomes, we're going to times this one by 3. So 3 times R2 minus 4 times R1. What that's going to do is 3 times this is 12, 4 times this is 12, and when we minus, we get 0. So we're not touching the first line, so it just stays the same as 315. So we've got 3 times this is 12, minus 4 times that, which is 12, which is 0. We've got 3 times this, because it's 3 times the second row. 3 times this is 6, minus 4 times that, which is 4. So 6 minus 4 is 2. 3 times this is 24, minus 4 times this is 20. So 24 minus 20 is 4. And we can do some other things there. We can divide this row by, or R2, we can divide by 2 and we get it a bit nicer perhaps. We get 3, 1, 5, 0, 1, 2, because we're just dividing the whole row by 2. And straight away we can read off that y equals 2. So from here, we've got that y. Remember, this is our x, this is our y. So we've got y equals 2 straight away. Then we can substitute the y equals 2 back in. And when we do that, we get 3x plus 2 equals 5. And that's also fairly easy to solve. 3x plus 2 equals 5. So 3x equals 3, x equals 1. And there's our answer, x equals 1, y equals 2. And we can substitute them back in to make sure they work for both sides. So that's a very simple 2 by 2 matrix. Let's have a look at a 3 by 3 matrix. And obviously there's loads of places that you can make mistakes. But here we've got 3x plus y plus z equals 6. We've got x plus 2y minus z equals 5. X minus y minus 2z equals 3. So again, I've just written the augmented matrix like this. Okay. 3x plus 1y plus 1z equals 6. So 3, 1, 1, z, 6. Okay. Again, we're not going to do... Now, we could probably swap some of these around to get a 1 here, which would be nicer. And that would, I would probably do it that way, but we won't. We'll just leave it like this just for this time. So we're not going to change the top row at all. So we'll leave that as 3, 1, 1, 6. What are we going to do to these other rows? Okay, so row 2 is going to become, we're going to do 3 lots of row 2 minus row 1. And I always just start with the R2 becomes 3R2 minus R1. Sometimes it's just written like that. So let's have a look at this. So we're timesing this by 3 and then minus in R1. So 3 lots of 1 is 3, minus 3 is 0. That's the whole point of it, to get rid of this 0 here, and we're going to try to get rid of that 0. So 3 lots of this is 6, minus 1 is 5. 3 lots of this is minus 3, minus another 1 is minus 4. And remember again, it's 3 lots of R2, so 3 lots of 5 is 15, minus R1, so 15 minus 6 is 9. Okay, now let's have a look at the second one. How are we going to get rid of this line? It's going to be pretty much the same. R3 is going to become 3 lots of R3 minus R1. So 3 lots of this minus R1. So 3 lots of this is 3, minus 3 is 0, exactly what we want. 3 lots of this is minus 3, minus another 1 is minus 4. 3 lots of this is minus 6, minus another 1 is minus 7. 3 lots of this is 9, minus 6 is 3. So that's the first step. We're trying to get rid of this. Now we're trying to get rid of this minus 4. So a bit more complicated, this one. R3 is going to become, and it's all operating with this because we want to use R3 and R2 now. So R3 is minus 4. So we're going to do 5 lots of this, 5 lots of R3, and we're going to have to add 4 lots of R2. So that's our little formula of what we're going to do. The reason why we use R3 and R2 is in this first one, 5 lots of this is 0, plus 0 is going to be 0. So we haven't touched the first and the second rows. This still becomes 3, 1, 1, 6. This becomes 0, 5, minus 4, 9. Now, here's where we've got to do our work, and there's loads of places we can make mistakes. We know that that's 0. Here, 5 lots of this becomes minus 20, plus 4 lots of this, which is 20. Minus 20 plus 20 is 0, exactly what we want. Minus 5 lots of this is minus 35, plus minus 4 lots of this is 16 is minus 51. Okay, so 5 lots of this is 28. Sorry, 35. 5 lots of 7 is 35, minus 35, plus 4 lots of this is minus 16. And we do exactly the same here. 5 lots of 3 is 15, plus 4 lots of 9 is 36. 15 plus 36 is 51. Now that looks not the greatest, but if you look down here, we've basically got minus 51z equals 51, and we can divide this row by 51 if we want, or we might even divide it by minus 51. So what we end up with is 3, 1, 1, 6, 0, 5, minus 4, 9, 0, 0, 1, minus 1. And the whole point of that is straight away we can say from here that z equals minus 1. So z equals minus 1. Then we can say, okay, well, if z equals minus 1, from this row we've got 5 lots of y minus 4 lots of z equals 9. But we already know that z is minus 1, so we get 5y plus 4 equals 9. So 5y equals 5, y equals 1. Nice simple equations. And then we can substitute it into, we've got a z and a y, and we can substitute in the first one. We've got 3x plus y plus z equals 6. And we know that z is minus 1 and y is 1, so we've got 3x plus 1 minus 1 equals 6. So 3x equals 6, x must be 2. And that's all it is. The only other thing that we might do is try to take this down so there's 1s across the diagonal here. That would mean dividing this by 3. So we get 1, 1/3, 1/3, 2. We'd obviously divide this by a fifth and we get a 0. Sorry, divided by 5. 1 minus 4/5, 9/5. And obviously this one just stays as is, 1 minus 1. And that's all Gaussian elimination is, or matrices, and that's why we can use matrices. It's a nice simple way of solving simultaneous equations. It's just a little pattern or a little format. Thanks.